or not, this is the factor. Then whether uh, nearest to confluence of river and sea, nearest to the confluence point between the sea and river, because that is where also salinity gradient exists. Okay, precipitation, how much precipitation take place in that location, that particular location, that is also can be another factor. So there can be multiple factors. You can take 50 odd, 60 odd factor, but less the factor it is better. But also less means we are compromising quality. More means we are increasing the quality, but requirement of data becomes huge, and also requirement of computational architecture which can process this amount of data also get increased. So this is the once the decision tree you develop means this is the goal. Goal means to select the location for sensor installation. Now you'll use some criteria to evaluate this location with respect to the goal, your goal, whether this location can be used for sensor installation or not. For that, you are using this hydrodynamic activity of that location, cost for installing in that location, data accessibility and availability, environmental constraints, technological constraint, etc. After then it comes alternative or factors. Okay, so with the help of each of these factors, actually the locations will be evaluated for its suitability in installing a sensor on that location. Okay, so these factors can be many things: distance nearest to city, distance from power source, tidally active or not, confluence point or not, how much precipitation is there, and various other different factors can be used. Now, to decide which factor is how much important with respect to this goal, each of these criteria will be used to compare each of these alternative. Okay, and then the resultant weightage of importance for each of these alternative will be decided, and with the help of that you can create a index which can be equals to Wm multiplied by the magnitude of the factors divided by the Wm, right? So this W is the weightage of this factor and Fm is the magnitude of the factor. This is the summation of all this weightage used for all the factors. Generally it is equals to 1, and this weightage will be defined or determined by the MCDM technique that I discussed. Application of aggregation methods. Okay, these aggregation methods mean HP method, ANP method, electric method, etc. If you are using MCDM technique, and if you are using that bioinspired optimization technique, then what happen is then this index become your objective function. W becomes the design variable. Fm become the magnitude of the factors for a certain location, and then if you divide it like this, and if you vary Wm from 0 to 1, then the point at which y become maximum becomes the optimal weightage of the optimal or the point at which y become maximum, because suitability, this is more this indicator, this means this indicator I